everyone. So today we are going to talk about the parabola function, and this is one of the most important functions in mathematics that is also applicable in physics. You'll see this when you start talking about vertical projectile motion. So for now, I'm going to strictly focus on the three forms of the equations. I'm going to talk about the shape of the parabola function. I'm going to talk about the vertical shift. I'm going to talk about the intercepts. I'm also going to talk about the domain and the range. So before we can talk about the three forms, the shape, and all the other stuff, let's just look at what I'm gonna refer to as the main form, because this is what we've been seeing since grade 10 when you were doing factorization. You would see an equation like this: ax squared plus bx plus c equal to 0. So this is one of the equations that we've been seeing since grade 10. So on this equation, the graph of this equation, it can look like this. This is just an example of how the graph can look. It can also face down. Note, it either faces up or down. And then this way we will call it a function. If it's facing up or down, then we call it a function. And I'm going to explain this on a video or a lesson where I'll be talking about grade 12 or adding grade 12 stuff. So for now, I'm going to focus strictly on what you need to understand in grade 11. So on this equation, we have different points on this equation that makes up this line. However, the main points that for now I'm going to talk about are these points. The point where the graph touches the x-axis and the point where the graph touches the y-axis. And we call these points intercepts. So a point, or the point where the graph touches the x-axis, we call that the x-intercept. And the point where it touches the y-axis, we call that the y-intercept. Note, this is the x-axis and this is the y-axis. And when we start counting on the x-axis, we start from 0 and then 1, 2, and etc. Going the other way, we start from 0, -1, and then -2, and etc. Then going downwards, -1, -2, and etc. And then going upwards again, 1, 2, and etc. So I want you to note this is the origin where we have 0, the 0 coordinate. So what this means is that if going up, this is at our 0, then this means that on the x-axis, this is where we have y equal to 0. And on the y-axis, this is where we have x equal to 0. That is why we say to get the y-intercept, we are going to replace x by 0. And to get the x-intercept, we will replace y by 0. This is because the x-intercepts are on the line where y is 0. And the y-intercept is on the line where x is 0. So, on this equation, y equal to ax squared plus bx plus c. This c is also the y-intercept. C represent the y-intercept. This is on this equation. C represent the y-intercept. And then this p is responsible for the horizontal shift, for the horizontal translations. For now, I'm not going to talk much on this. And then A, this is responsible for the shape. So if A is positive, then the graph will face up. And if A is negative, the graph faces down. So this type here, this is the type where A is negative. And this type here is a type where A is positive. Okay, and then I'm gonna move on now to what we call the turning point. The turning point. So again, still on the same graph. Still on the same graph. I want you to note that, let's say now I'm gonna make a new shape. Let's say this is our turning point. This is the highest point. The turning point on this graph is the highest point or the maximum point of the graph. This is our turning point. So remember, on this side, the graph was increasing and then got to the turning point, and then the graph starts decreasing. So this is the turning point. And then on this turning point, we can draw what we call the axis of symmetry or the line of symmetry. So I want you to note that with a parabola function, if this point here is a minus 1, 4, this point, and let's say this is 1, 6. This is just an example. And then let's say we have another point that is, yeah, so let's say this is another point. And then this point, the y value of this point will also be 4. I want you to know this. If they're on this horizontal line, these 2 points are on a horizontal line, the y-axis of this point will also be 4. And the x-axis will be such that the distance from this point to the axis of symmetry will be the same as the distance from this point to the axis of symmetry. So note, if this is minus 1 and this is 1, 6, the distance from this to this is just 2. So this will mean that again, the distance from this to this point will also be 2. And what that means is that our point here will be 3. This is what we mean by symmetry. So the distance from this line, from this point to this point, is the same as the distance from this point to this point. This is what we mean. And then the turning point is also one of the important points that we talk about when we talk about the parabola function. Then I've talked about the turning point and I've talked about the symmetry, the axis of symmetry. I've also talked about the intercepts. So now I'm gonna move on to talking about the range and the domain. Starting with the domain. The domain represents all the possible x values. So the domain represents a set of the x values. So if you look at this parabola function, the domain, for as long as it has arrows at the end, the domain will always be x element of real numbers. This is also the case on this one. The domain will always be x element of real numbers as long as the parabola function has arrows at the end. This arrows shows that this continues. So that is why we say the domain will always be x element of real numbers, meaning that all the x values are applicable in this case. And then with the range, when we talk about the range, we're talking about all the possible y values. What this means is that we are going to look at where does our graph start and where does it end. Because the parabola, it has a maximum or minimum. So on this one here, we have the maximum value. This means that our graph cannot go beyond this. So in this case, y be less or equal to the maximum value. If our maximum value is 6, then we'll say the range is y less or equal to 6. This is how we get the range. With the range, we're looking at the y values. Where does the graph start and where does it end? And another way you can also write this, you can also say it ranges from negative infinity to 6. And 6 has to be included. Note this bracket, we are including 6. And this one here, it's not inclusive. And then another important thing, if it was this one, the range will be, remember on this one we have the minimum value. So say the minimum value is negative 3. The range will be y is greater or equal to negative 3. That is how, this is how you are going to write the range and the domain. The domain is always x element of real number for as long as the graph is not limited. If there are arrows, it means the graph continues. So the domain will always be x element of real number. The range will depend on the maximum and minimum value. So another important thing that we're going to talk about is the three forms. I want you to note that a parabola equation can be written in three forms. I've talked about the first form where I said y is ax squared plus bx plus c. And note on this form I said c is the y-intercept. The second form that I'm going to talk about is the turning point form. And on this one we have y equal to a x minus p squared plus q. So this can be written as this, or you can also write it as y equal to ax plus p squared plus q. So this p and q are the coordinates of the turning point. Same, p and q represent the coordinates of the turning point. And then the third form is y equal to a x minus x1 and then x minus x2. So on this one, this x1 and x2 represent the intercepts. So x1 and the x2, they represent the x-intercepts. So remember, a parabola function can either have 0 intercept, 1 or 2. So this case here, it has 2 x-intercepts. So x1 will be, let's say this is negative 2, this will be x1, negative 2 will be x1, and if this is at 5, 5 will be x2. This is what we mean when we say x1 and x2 represent the x-intercepts. So these are the x values of the intercepts. And then I'm gonna go back to this first form and talk about this important thing that I didn't talk about previously. So on the first form, if you want to get the turning point, we are going to use the equation x equal to minus b over 2a. This comes from the quadratic equation. Remember, a parabola function can also be called a quadratic function. It's the same thing. So on the quadratic formula, or on the quadratic equation, to get the x, we say minus b plus or minus square root of b squared minus 4ac over 2a. So we only took this part. That is how we get to this. So if you don't remember this formula, write down the quadratic formula and then get it from here. This is what we took, minus b over 2a. This is how you will get the x value of the turning point if you are given the first form. If you are given the second form, all you need is P and Q. This represents the turning point. If you are given the third form, x1 and x2 represent the x-intercepts. So please, you have to be able to remember these three forms of the equations. And then now, I've already talked about the shape, but I'm going to talk about it again. So with the shape, I said if we have y equal to ax squared plus bx plus c, a tells us the shape of the graph. So if a is a positive number, our graph will look up. This is what we call a smiling face, and then if a is less than 0, our graph will face down. And then this is what we call a sad face. So if the graph is facing up, it means that a is a positive number. If the graph is facing down, it means that a is a negative number. So this is what it means. And then another important thing is obviously the shift. Our graph can go up and down. So when we talk of the vertical shift, when we talk about the vertical shift, I'm going to reference only two forms of the equation. I'm going to talk about y equal to ax squared plus bx plus c, and also y equal to x minus p squared plus q. So let's say this is our equation. Remember, c is the y-intercept and q is the y value of the turning point. So let's say this is our turning point, and this is obviously the y-intercept. C will be this value over here, and Q will be this value here for the turning point. It will be the y value of the turning point. So if we increase, let's say you add 2 to C, the graph will shift up. The same if you add 2 here, the graph will shift upwards. If we say -2 or -3, the graph will go down. It will shift downwards. This is what we mean when we talk about the vertical shift.